Chapter 4, Cognition. What comes after digital? What happens once we've connected everyone, that everyone's got phones, and we've got the ones and zeros flying everywhere, we've got a new global digital economy, new devices emerge, new kinds of technologies that allow us to interact with the physical and virtual and digital worlds in real time, where we have digital twins. What comes after all of that? Well, the answer is already in front of us, because we are now in the midst, concurrently, we are in the midst of an artificial intelligence revolution. We are now teaching our machines to learn dynamically from their environment. We're teaching our machines to read, we're teaching them to write, we're teaching them to see. Most importantly, we're teaching our machines to analyze and to predict in ways that we once thought were completely impossible. You've probably heard this word, artificial intelligence, thrown around a lot. But you might also think that it's perhaps a little bit like teenage sex. It's something that everyone talks about, but no one's actually doing. And yet, if you look at the top 10 most downloaded iPhone apps in 2019, every single one of them employs artificial intelligence. If you've used one of these applications in the last few weeks, well, then you have already used AI. So YouTube, Instagram, TikTok, Netflix, they all use artificial intelligence algorithms to try and make better recommendations. And Facebook uses it to alter and edit your newsfeed. Amazon uses it to make product recommendations. Messenger uses it for its chatbot features. Gmail uses it for autocomplete. Google Maps for routing and for directing traffic. And Snapchat, well, no cute cat videos without an AI algorithm that can recognize what's actually in the video. And yet, in the business world, when we hear AI, it's usually accompanied by pictures like this. Once again, in the same way that disruption almost always tends to be a picture of a wave, well, AI usually is some kind of creepy robot humanoid that the marketing team to resist. They select these from stock images, and you creatures, or maybe a business executive over there touching some brains, some AI. Here's a robot doing some super fast AI programming on some kind of really weird screen. I don't even know what this. Here's another human being touching a hand. Interesting how these robots always seem to be doing exactly the same thing as the artists from the. Here's something that looks very cool but means absolutely nothing. I don't know what EXO-12 means at all, but it looks. And here's artificial intelligence versus COVID-19. In the same way that COVID-19 actually looks nothing like that, here's a real picture of what that virus looks like. It just turns out that the artists have all embellished it. AI looks nothing like this in real life. If you want to see what AI actually looks like in the real world, it looks a little bit like this. And the best way of thinking about artificial intelligence, the way to actually think about it, is that artificial intelligence, very simply, is a new way to tell computers what to do. Here's the old way of telling computers what to do. It's called if this, then that. This is basically the way that code on computers has run for decades. And you've probably used this yourself. I'm assuming you probably had a go at programming a little bit maybe in Excel, and you've probably put this into a sheet where you've done a function that says if a value equals this, or if a value is larger or smaller than this, then do that, and if the value is larger or smaller than that, then do this. So this is something that's quite familiar to us, all of us. This is something that we've gotten used to over the years. So that's the traditional way of speaking to computers. In 2012, though, a team at Google figured out a way to teach computers to look at hundreds of thousands of images and then recognize catness in a video. So the computer looks at the shape of all of those images, and over time, it eventually recognizes different configurations of pixels in the image, different configurations of data, and then the computer starts to recognize that something looks like a cat. And so eventually the computer can recognize what a cat looks like, and then it can recognize what a dog looks like, and then a duck, which is very cute. But it's also very useful because you can also train a computer to recognize what fraudulentishness or nishness, that's not even a word. You can you can teach a computer to recognize something that looks fraudulentish, or you can teach a computer to sound Obama-ish.
Never thought that hip hop would take it this far. Now I'm in the limelight because I rhyme tight. Time to get paid, blow up like the World Trade. Born sinner, the opposite of a winner. Remember when I used to eat sardines for dinner. Peace to Ranji, Brucey, be Kid Capri. Funkmaster Flex, Lebec Starsky. I'm blowing up like you thought I would. Call the crib, same number, same hood, it's all good. And if you don't know, now you know, nigga.
So, traditional programming, here's the way to think about it. That's explicit instructions. If this, then that. Artificial intelligence, a new way to speak to computers. It tells computers to learn from examples. You give a computer a data set, you give it training data, and you tell it to learn from examples. And eventually, it can recognize that data for itself. And it can also identify patterns in that data that human beings could never see before. Now, while that is mostly boring, it involves a lot of data wrangling, but it's also incredibly useful because 8 years later, 2020, artificial intelligence is now starting to be applied across almost every sector of the global economy, including many sectors that are crucial to the future of the African continent. Let's start with healthcare. In the image over here, what you can see in those yellow boxes is where artificial intelligence has managed to spot a tumor that 5 of the world's best radiologists failed to uncover. And in a study done in Nature a few months ago, an AI program that was trained on 15,000 different mammograms was able to reduce false negatives by 9% and false positives by 6%. Infoversion, a startup based in Beijing, has now been able to 1 million different scans from Chinese hospitals, and it's using those to train and test algorithms. For the Chinese, gathering medical data is much easier because patient populations are larger and the burden of privacy regulations are smaller. And their newly launched infrared CT pneumonia scan for the fast detection of coronavirus is currently helping doctors in the front lines in more than 32 hospitals all over China. It normally takes doctors around 15 to 20 minutes to scrutinize one image of lung scans, whereas Infoversion's AI can process the visuals and put together a report in under 30 seconds. In our hospitals, similar algorithms are looking at the brain scans of 6-month-old babies to determine whether they are likely to have autism. Human clinicians have to wait until the kid turns 2. And those similar algorithms can also detect Alzheimer's up to 9 years before human doctors can. In the United States, a company called Ezra now offers a full MRI scan, which is analyzed by an algorithm to pick up cancer. It's 93% accurate, making it far better than a human physician. So think of this like a cancer checkup. Every 2 years, you go in for your cancer scan, and then in time, hopefully your insurance company even pays for it. Remember, early detection is the best method for survival. And you don't even need to go and lie in a fancy machine. Remember, you've got a fancy machine in your pocket. This is a company called Skin Vision, and you can download it right now on the App Store. It has an image recognition algorithm that's 95% accurate. That is compared to the world's best dermatologists who get it right 92% of the time, and family doctors who get it right about 80% of the time. So they are able to diagnose skin cancer using an image recognition algorithm, and it costs about $30 a year. So does that mean that all of the radiologists and the skin cancer dermatologists are going to be out of a job? Well, no. And I like what Curtis Langlotz, one of the world's best radiologists, has to say about this. He says that artificial intelligence will not replace radiologists. Those radiologists who use artificial intelligence will replace the ones who don't. And if you're trying to think about artificial intelligence disruption in any industry, just replace the word radiologists with any job title of your choice, and you'll start to see it's not about the machines versus the humans, it's about the machines and the humans working together. Remember as well that this stuff saves lives. This is one of my favorite examples. It's an AI algorithm called Ubenwa. It's based out of Nigeria, and it listens to the frequency and modulation of infant cries to determine whether a child is likely to have birth asphyxia. In other words, a nurse with a phone in a birth ward can instantly pick up whether the child has birth asphyxia, and birth asphyxia is the third leading cause of infant mortality worldwide. Here's another great example of AI saving lives. These two South African doctors, Dr. Ernest Dako and Dr. John Sargent, met at Harvard Medical School, and they wondered whether they could apply data science and artificial intelligence to HIV treatment in South Africa. What they'd figured out is that there are two big sources of inefficiencies in HIV treatment. The first is that a lot of the important data is trapped in paper format. So that includes stuff like payroll data from healthcare clinics as well as lab data from patients. And the second problem is staffing. There's no way to allocate valuable resources to the clinics that need them most. And because there are so few healthcare workers, no one has the time to do this kind of analysis. And so they built an app. It's called Vantage, which aggregated all that data and then uses artificial intelligence to make recommendations. And almost straight away, KwaZulu-Natal emerged as the hotspot. It turns out that there were a few clinics that were disproportionately important in the work being done, which then allowed managers to zero in on needs and focus resources where they were most needed. Since 2014, Vantage has been used to help healthcare workers test 5.5 million people for HIV and help 530,000 people start an antiretroviral therapy. It also makes it easy for staff workers to enter what they're doing. So staff workers can enter their activities and the AI app can identify what's happening in the background. Since last year, they've been analyzing that data, and this has been allowing the AI to make recommendations. So let's say a clinic's doing really well on the 90% target for, let's say, getting all HIV people to know their status, but it's way off target on the third 90% of making sure that 90% of people are on treatment and that it's been virally suppressed. The analysis can show that the problem is that the clinic is short by one nurse and that they're running out of medication to distribute. When this application launched in Ugu, one of the most HIV prevalent wards in KwaZulu-Natal, in 2019, only 3% of the staffers there were recording their daily tasks. By October, the total had risen to 65%. And on November 27th, 2019, the health minister, Zweli Mkhize, officially announced that the first high prevalence district in South Africa, the Ugu district, had been declared to be in HIV epidemic control. That same application has now also been used for COVID screenings across South Africa. And through the use of artificial intelligence and data analytics capabilities, the app also triggers contact tracing and allows hospital managers to prepare their facilities for potential COVID-19 patients by predicting resource allocation needs such as ICU bed usage and critical stockouts. What about other industries? Well, in finance, machine learning and artificial intelligence is already ubiquitous. The global stock market is now dominated by algorithms. According to Deutsche Bank, 90% of equity futures trades and 80% of cash equity trades are done by machines. And in October last year, for the first time ever, the world's stock of passive equities managed by computers surpassed those managed by humans. The stock market doesn't run on the rowdy floors of New York anymore. It runs on computer servers in New Jersey. Since 2013, PayPal has been leveraging fraud detection algorithms to protect their customers' digital transactions. Over the last few years, thousands of purchase patterns or features have been learned by the security detection system, which can now decipher, for example, the difference between transactions that are a bunch of friends who are buying a whole lot of concert tickets at the same time, and a thief who's making the same kind of purchase with a list of stolen credit cards. PayPal's deep learning approach, using AI to detect fraud, this approach to transaction security has reduced their fraud rate to 0.32% of their revenue, which is 1% less than the average rate seen by most e-commerce merchants. We've also seen the rise of robo-advisors, which is where an algorithm manages your money for you. And for millennials, this is now the normal way of managing their stocks and funds. This is an app that I use called Raise, where the majority of my funds have now been deposited. It means that all of my investments, or the majority of my investments, are now being managed by a machine. I can set the parameters that I want it to use, and the machine carries out trades and investments automatically for me without the bias of a human being. What about bots, the annoying programs on the internet that speak to you? I mean, most people say that they don't want to speak to a machine, they don't want to interact with a bot, they want a real person on the other end of the line. But what happens, for example, if you had an insurance company where the interaction was so seamless and so quick that you never even noticed that it was an algorithm in the first place? You see, that's the beauty of code. It can operate far quicker than a human, and it can make a decision in seconds. Get paid in no time and go party. I think we can all agree that that's something we're all into. This is what happens when a company takes the next step in the digital revolution, when you move from thinking about digital to thinking about cognitive. Some of the world's oldest and stuffiest and most conservative organizations are jumping on board. This is Slaughter and May. It's one of the most prestigious law firms in the world. It was founded in the 19th century, and they bought a startup from London Silicon around about 4 years ago. It had an AI system that could pick out mistakes in documents before they conducted a big merger and acquisition. Here's Jane Stewart, who's the head of knowledge and innovation at Slaughter and May. She says that they're now using artificial intelligence across the entire organization, using it to surface patterns from our store of documents and precedents. It's useful anywhere that we have unstructured data. And as a law firm, they've got a lot of that. Here's Alex Woods, their director of knowledge and innovation. All new hires to our company have to learn how to use artificial intelligence as part of their training. We no longer see this as separate from the practice of law. Let me just repeat that for a second. This is one of the oldest and most prestigious law institutions on the planet. They've been around for longer than almost any other law firm. And here is their director of knowledge and innovation saying, we no longer see artificial intelligence as separate from the practice of law. Don't have to be a big, massive law firm either. This is a small accounting firm. I think it's got about 15 people. They're called Garbleman Winslow. They are somewhere in the United States, I think Massachusetts. Here's a photo of them at their Christmas party. There are no hoodies. There are no hackers. No ping pong tables in sight. This is as old school as you get. And yet, for the last 2 years, they've been using an AI audit program called MindBridge. Here's one of their partners, Samantha Bowling. We used to do random sampling for audit. AI is far more comprehensive. It alerts us when things don't look right, and it tells us where to start. This technology is available to everyone. As Samantha said, if we worried that we didn't invest in AI, we'd lose our auditing business to larger firms. And the small firms, and this is crucial here, the small firms are lucky. We're not stuck on legacy platforms. You can implement this technology for less than $10,000. In other words, you have no excuse anymore. In retail, it's a game changer. Here's Walmart. They have a new concept called the intelligence store. What's really interesting here is you can see in the roof over there are hundreds of different cameras which are monitoring the store in real time. And that means, for example, those cameras can look at the bananas and they can spot when the bananas are going to be too ripe, when they need to replace them, when they need to replace stocks. Look at the back of the store over here. You can see entire data racks, huge data centers in the back of the store. At H&M, they've got data scientists reviewing the purchasing patterns. They're trying to forecast trends months in advance. The retail giant employs them to review purchasing patterns of every item in each store, and then the data incorporates all of the information from people coming in and also the websites. And it also considers data from external sources to try to figure out where trends are going. It's not a one-size-fits-all merchandising approach. It means that every single store gets individualized recommendations about what kinds of stocks to hold. What they're working on is being able to, for instance, calculate and quantify how many cases you're going to buy of any item. And then with precisely honed demand forecasts, their supply chains can use only the resources they need and no more. Without that kind of precise demand planning, the result is waste, which historically has been a big problem for the fashion industry. And this doesn't mean throwing out the old expertise either. Here's Arti Zegami, who's the head of advanced analytics and AI at H&M. He said it's important that we don't throw out 70 years of fashion experience. So instead of artificial intelligence, he prefers to think of it as amplified intelligence, which is a nice term. It's about augmenting human capabilities rather than replacing them. Once again, similar to Curtis Langlotz. At Olay, in retail, again, another concept here, they've been able to get an AI algorithm that can take a photo and look at a video of the customer's face and then be able to provide the customer personalized skincare recommendations. Since employing this kind of algorithm, Olay has seen a 100% improvement in sales conversions, 33% reduction in their online bounce rate, and a 40% increase in the average basket size of online shoppers. AI, what they've done here is they've figured out that if everyone's got a phone and if you've got AI algorithms in the back, then you can use that for more sales. What about something like agriculture? Agriculture is the largest employer of people on the planet, and it is a vitally important sector in sub-Saharan Africa.
The whole idea of Plantix is that we can use modern technologies to help farmers everywhere in the world. We use machine learning, artificial intelligence and big data to derive insights. But this might sound a bit abstract to you, so let me give you an example. Let's say you see a sick crop in your field. You can just easily take an image with Plantix. This image is sent to our servers, analyzed by deep neural networks, and we will tell you on the spot and instantly what is wrong with your plant.
So if you are one of the 500 million small-scale farmers on the planet with access to a smartphone, you can now be as good as the world's leading agronomists at figuring out what's wrong with your crops. Turns out you don't even need a smartphone. A few years ago, Microsoft developed an artificial sowing app which they used in a number of districts across India, and it was trained on previous weather data, and then based on the past data, the app was able to text farmers with information about the best time to sow. The best part of this is that the farmers didn't need to install sensors in their fields. They didn't need to spend anything up front. All they needed was a feature phone capable of receiving text messages. And those farmers who participated in this program were able to achieve up to 30% higher yield per hectare just through receiving better advice. And so when you combine all of this together, you get one of my favorite companies anywhere on the African continent, Apollo Agriculture, who are using artificial intelligence, text-based services, mobile money to really bring all of this together.
Kile kinafanya unajua ukiwa una pesa unakuwa inaitwa nini, kufikiria, mafikirio ni mengi kwa akili, kila wakati unakaa bila nini. niseme hapo kabla Apollo nakuwa kwa eka ama kwa nusu eka, unaona ninavuna gunia moja unusu, na kwa wakati ule nimeingia hii kwa Apollo nakuwa na gunia kutoka 7 9 hivi. Kujinunulia hiyo mbolea na mbegu za mahindi, Apollo inaweza saidia mtu kama huyo. Ile tofauti naona mazao inakuwa sawa, mvua ikinyesha hakuna kuserewa, ni kupanda. Ikinyesha tunaingia kwa shamba, tunapanda na tunalimia na tunangojea mavuno. Kwa vile yale mavuno tulikuwa tunavuna ni mingi kuliko vile ya zamani, kabla hatujaingia huko. Kwa hivyo nikaonelea hiyo mavuno ni mingi, kuna chakula ya kutosha. Ninaonelea wakati mwingine na naingia huko kwa nyumba na toa magunia ya mbembe 1 2 kama 3, nikawicha, nikapeleka hao watoto shule na ikapaki hao yale watakuwa wanakula.
Okay, let's bring it even closer to home. I know that a lot of you who are listening to this work in mining and resources. And as with so many of these other industries, it turns out that artificial intelligence here is a game changer. The 3 things that AI does best in resources and mining is that it changes the value of the hardware, it makes operations more efficient, and perhaps most importantly, it improves safety. This company, for example, MineSense, works by attaching a device to the shovel bucket that uses X-rays to virtually sift through the bucket's contents and inform the operator in real time about what's actually there. On board the shovel, software does a quick calculation. Is the ore grade as high as expected or not? That data then flows to the mine's fleet management system, which directs the load towards processing or away from it. The data also is sent to a cloud-based warehouse where data scientists have applied different types of analytical and machine learning models, and then those insights are shared back with the mine operators on real-time dashboards. The result of these technologies being employed just in one place on the shovel results in improved mill productivity, reduced energy use, and less water consumption. These technologies are also slowly being brought into African mines. A company called Dwika Mining Services is using a technology that's been developed by an Israeli company and then deployed in Australian mines to help use video analytics to remove humans from unsafe areas. So the algorithm can spot that people are there, they shouldn't be there, well, that's an unsafe situation, and because the algorithm knows it, it's able to alert data science, it's able to alert mine operators so they can avoid a problematic situation. When you apply that kind of video analytics technology and you put it together with temperature sensors, it also allows you to automatically scan workers who are entering the mine to determine whether they have higher temperatures, whether their body temperatures are higher than normal, and figure out whether they have coronavirus. These technologies are being deployed right now by a listed PGM group in South Africa and a zinc lead copper group in Africa. Or you can just be like the Chinese and employ the technology across your entire mine. What about manufacturing? Well, those same kinds of algorithms that you saw employed there in mines are being brought onto production lines. This is a company based in California, and the video analytics are monitoring what people are doing on the production line there to try to figure out whether there are any small efficiencies or improvements that can be made. Think about that technology employed in a number of manufacturing hotspots across the African continent. General Electric say that they're using artificial intelligence for computational fluid dynamics, and that's reduced the amount of time that it takes to analyze the computational fluid dynamics for a traditional jet engine from weeks down to a matter of hours, and it's reduced the overall design time by 50%. And of course, remember that General Electric has sensors attached to those jet engine turbines as well, which means that they can use that data to make future improvements.
Sensors fitted to the engines of Emirates Boeing 777 aircraft collect a wealth of data that is analyzed using specialized software at GE's Middle East Advanced Aviation Technology Center in Dubai, a first of its kind worldwide. Pioneering algorithms provide advanced notice prognosis, leading to a more efficient maintenance program and improving engine performance. The result so far? 20% more time on wing, a significant reduction in unplanned engine removals, reduced labor costs for engine changes, and the ability to troubleshoot before problems appear.
I hope that you're starting to pick up the pattern here. In every one of these cases, what you're seeing is that when you add cognitive technologies to hardware, when you embed artificial intelligence into your systems and you allow it to drive hardware, you get the kinds of productivity and efficiency improvements that would have been unimaginable just a few years ago. When you add artificial intelligence to a car, for example, and you allow it to drive, well, then you change the value of what the car can do. Waymo, the leading company in this area, has logged more than 30 million kilometers of testing at public roads, and in October last year, quietly and largely unannounced, one of their minivans slowed down on a street somewhere in Phoenix, Arizona, to pick up members of the public, but there was no driver there to greet them.
Great.
It doesn't have to be a car either. You can change the value of almost any piece of hardware by adding cognitive technologies to it. Imagine a bike that follows you and listens to your commands. Nowhere is this phenomenon more prevalent and more important. Google is the largest private purchaser of clean energy on the planet. They have a commitment to getting all of their energy from clean sources, and so they have more than 50 renewable energy projects around the world. Most of them are in wind. About 2 years ago, they started looking at historical weather data on their wind turbine sites, and then using machine learning, artificial intelligence, to analyze that data and make future predictions. And as a result of that, they're able to then make the prediction and tell the machine when to turn on and off. That's resulted in a 20% efficiency improvement. And so what's really interesting here is that there's been no change in the hardware. The wind turbines didn't get bigger, didn't get more taller, the blades didn't get more aerodynamic. What changed was the software that runs those wind turbines. And as a result, Google got a 20% efficiency improvement. When they started employing that kind of technology in their data centers, the results were unbelievable. Here's Google's Chief Sustainability Officer, Kate Brandt. She said that as a result of employing machine learning in their data centers, the average increase in cooling efficiency has been 30%. So they've been employing this across the whole world, across all 14 of their data centers, and that's already saved them over $1 billion in avoided energy costs. Once again, the hardware hasn't changed here. What's changed is the software. And that is why cognitive technologies are so extraordinarily powerful. With great power, of course, comes great responsibility. There's something deeply unsettling about many of the technologies that we've talked about here. I mean, we've heard about how police forces around the world have been getting their hands on facial recognition technologies, and that is like stuff out of the worst nightmares of George Orwell and Aldous Huxley. I mean, we've all seen Black Mirror. We know where this one ends, right? Well, I bet you didn't hear about what happened in Delhi. But perhaps you didn't hear about what happened in Delhi, India, where the police got their hands on facial recognition technology about a year and a half ago. They received 200 facial recognition glasses. And you know what the first thing they did was? They uploaded a database of all of the city's missing children. And then they visited all of the city's orphanages and took photographs of the children there. And in the space of 4 days, when they first trialed this technology, they were able to identify 3,000 missing children. Over the last year, they've been able to identify a further 10,000, reuniting some of these children with their families for the first time in years. Remember, it's not the technology, it's what you do with the technology that counts. And that's why, for me, the most extraordinary application, and I think the one that I'm most excited about for artificial intelligence, are these little devices. These are some of the world's first in-ear instant translation devices that allow me to speak in real time to anyone in any language. For Hitchhiker's Guide to the Galaxy fans, that is the real-life Babel fish. And like so many of our greatest stories, this one starts with love.
I came up with the idea. Elodie, put this in your ear.
Je mets ça dans mon oreille,
Yeah, put it in your ear.
comme ça.
Yeah.
Ok.
Can you hear me in French?
Pouvez-vous me entendre en français?
Since the dawn of time, language barriers have been one of our biggest barriers to human progress. Thanks to these cognitive technologies, within the lifetimes of all of you, all of us listening to this presentation, those language barriers are going to disappear for everyone. And when I say everyone, I really do mean everyone.
Hello. My name is Thomas. And this is Naveed. We are inventors in the Lemelson MIT Student Prize Competition.